In today's lesson, we will be discussing about relations and functions. First of all, what is a relation? Basically, a relation in math is how a set of numbers relates to another set of numbers. Typically, these set of numbers are called domains and codomains. But what is a domain and a codomain? From the image shown, a domain is the set which contains numbers called objects. A codomain, on the other hand, is the set which contains numbers called the images. The range of a relation is defined by the images which are related to the objects. In this case, the range is x and y. In math, there are four types of relations. The first is called one-to-one relation. For one-to-one relation, each object has only one image and vice versa. The second relation is called one-to-many relation. In this case, there has to be at least one object having more than one image. The two red arrows show the object 4 having more than one image, making this a one-to-many relation. The third relation is called many-to-one relation. In this case, there has to be at least one instance where two or more objects are mapped to the same image. The two blue arrows show that objects 2 and -2 are mapped to 4, making this a many-to-one relation. The last relation is called many-to-many relation. This relation is a combination of both the one-to-one and many-to-many relation. From the example, we can observe red and blue arrows, which represent one-to-many and many-to-one relation, respectively. Now that we have understood relations, let's move on to functions. So what exactly is a function? It is a relation where every object has only one image. So only two types of relations are possible in a function. They are one-to-one and many-to-one. A function is responsible for transforming the input value into the output value. A simple analogy would be a chocolate factory where the cocoa beans are turned into chocolate. We will now go through a few examples of solving problems involving functions. Let's take a look at how to find objects and images for a given function. Now, in this example, we are given a function and we are expected to find the image of 2. That means that 2 is the object. We can find the image by substituting the object into the given function. So replace every x value with 2. And we get an image of 14. Now we are to find the object of 3. That means that 3 is our image. We can compare fx, which is our output, with the image of 3. Now we know that fx is equals to 5x plus 4. So we can replace fx with 5x plus 4. After simplifying, we get x equals to -1/5. Sometimes an image can have two objects. This occurs when a function has a modulus value. In this example, we are to find the image of 7 for the given function. Like in the previous example, we can compare fx with the image, which is 7 in this case. In order to get rid of the modulus symbol, we need to have only the modulus value on one side of the equation. After that, we can get rid of the modulus by putting a plus-minus symbol to the value in the other side of the equation. After simplifying, we obtain two answers. Now let's take a look at an example involving involving unknown values. In this example, we are to find the unknown values of the given function. The unknown values are m and n. The diagram on the right shows us the objects and the images of the function. Since there are two unknowns, we will need two equations to solve this problem. We can do that by substituting the two sets of given object and image into our function. Let's start by substituting object 1 and image 2 into the function. After simplifying, we obtain m minus n equals to 4. Now let's rewrite the equation in terms of m. So that is our first equation. Now repeat the process with object 3 and image 5. After simplification, we obtain our second equation. Now we can substitute equation 1 into equation 2. Notice that m is substituted with 4 plus n. After simplifying, we get n equals to negative 1. Now that we know the value of n, we can now find the m value. We can do this by substituting n equals to negative 1 into equation 1. After that, we obtain a value of m equals to 3. Now let's take a look at how to find objects mapped onto itself. When an object is mapped onto itself, this means that the object and image have the same value. In this case, we are to find the value of object x, which is mapped onto itself for the given function. Since the object maps onto itself, the image of object x is also x. So we can compare fx with x. After a few steps, we obtain x equals to half. Thank you for watching, and I hope you find this tutorial helpful.